Okay, so if you want to launch the right application to play with, I invite you to install PostGIS and OSM to PGSQL. Obviously, if you have also a Jupyter notebook, it will help. You can also use QGIS as a visualization tool. So it's up to you. As Natalia just said before, we have to wait a few minutes to have a connector, and I will be able to show you dynamically this workshop. But on the meantime, for those who want to play with, just install the right software. So what this tutorial will be about, it will be about loading spatial data inside the PostgreSQL, and there will be three kinds of data. So we'll play with vector data, with raster data, and with vector data from OpenStreetMap. So there will be a different kind of data, and we'll play with them to show you how we can perform spatial analysis with different kind of data and try to make sense with this kind of query. The other bit specific thing about this tutorial, I try to integrate all the PostgreSQL stuff with the Python. So it's a bit why I use Jupyter as a container for this workshop. So everything is online, so you can also have a look on this workshop. Yes, thanks. What we do at the really beginning, we begin to create a database. So it's a new one called OSM, like OpenStreetMap. Yeah. Okay, thanks. So we create an empty database, so called OpenStreetMap, and we just add the PostGIS extension to allow this empty database to be able to perform with any new kind of spatial operation. So it's as easy as create extension PostGIS on the database name. So here, this one, we just add the spatial support on this empty database. And that's it. It's as easy as that. Here, we check that everything is fine on the spatial support from our database. So as we already just create the extension, the spatial extension, we want to check that everything is fine. And this really function, we came from a PostGIS function list, is the kind will bring any information about the version already installed related to, oh, I switched, sorry.
It's your computer.
It's mine. Oh, brilliant. Thanks. So we create the extension, and then with the PostGIS full version, we can check that everything is fine on it. I just check it dynamically to be sure that everything is fine too. Yeah. So what did we get? We get first the information that the special extension from PostGIS is well installed, because if it wasn't the case, we've got an error message on the other side. We've got also information about the version we've got installed there. So related to PostGIS, related to Geos, related to some different kind of function installed with PostGIS, here with raster, and so on. So there is two kinds of information. What different kind of library are installed, yes or no, and what version are installed for all this kind of library. There is several kinds where really matter. For instance, so we've got Postgre with PostGIS support, and PostGIS itself is based on several other kind of library tied with them, with it. So there is Geos, Posh4, libxml2, and GDAL. This one, Geos, will be used to perform any kind of spatial operation. It could be, for instance, an intersection. It could be to perform spatial union on dataset. Posh4 will be used to reproject and to change the projection of your feature. libxml2 is a bit obvious, but it will be used, for instance, to parse GML or KML. And GDAL will be used to access to raster data. It could be some kind of imagery or grid data. For instance, if we want to, here I've got the raster support, we need the GDAL library. So if we want to play with raster, we need GDAL. And this one, and this one are mandatory to use PostGIS. So you don't have any choice about them. And it's quite important to notice that the Geos version is meaningful, and it's kind of advice to use the latest Geos version available related to PostGIS. Because each time you increase your Geos version, you upgrade the performances, you improve the performances, and also you've got the latest function available, and there is a brand new function, shiny ones, who came on each new version. So at this step, we already know that both we've got a working installation, and we've got anything we need to go further. There is some extra library. We are not there installed. There is, for instance, sfcgoal with really close to Geos, except that sfcgoal is able to deal with 3D spatial analysis. And for instance, with Geos, you are able to perform intersection in 2D, but with sfcgoal, you are able to perform intersection in 3D. So once we've done that, we can go here a bit further and create a schema. It's only to avoid to put any kind of data in any place. So we create a data schema, and then we are beginning to grab the data we need to play with. So this step is related to open data from the French government, and they provide some open data set. This one is related to administrative boundary in France. So there is a different kind of administrative boundary level. So we just grab them, unpack the folder. So there is a and the point is at the, on this that the different kind of files were uncompressed. The one meaningful for them are in shapefile format. So at the end, the SHP extension is related to shapefile format. It's a quite well-known format for spatial data. It's an old one too. So sometimes we need to deal with some old stuff, things are related, for example, to encoding in text and so on. But it's well known. And there is a native loader provided with PostGIS to load this kind of data set directly inside Postgre. So the loader itself is called SHP to PGSQL. And this loader is able to deal with SHP file and to transform them into SQL code, and Postgre is able to dig it. And here the point is related to the option we want to pass through the SHP to PGSQL loader. There is several options available with this command. If we look on the man, okay, so here there is all the options related to SHP to PGSQL, and from all of them, we wanna use sometime every time this option are related to the spatial projection we want to define on the load. I don't know if you're okay with that, but there is associated to each kind of geographical data set the information, the metadata information related to the spatial projection. So it's kind of reference, and we have to define it on the load step to be sure that we are okay with that. The I option is related to index. So when we add the I option, we said to PostGIS that at the end of the load, it will add a special index on our data. And if we look on the and here the D option is related to the ability to not use the insert or cross-flow, but to use copy to insert the whole data at once. So I said with the I option, there is a create index with called at the end of the load process. So once we've done that, we are able to look what we load, and here there is the structure for our table data. So here you've got the different kind of attribute columns, and here there is a new column with geometry type information. So you find back your SRID information, so the metadata related to the projection system is there. And here you find also the type of the geometry. So geometry is somehow a generalistic type, but is then defined more precisely with different kind of geometry type. And the main ones are points, polygon, line string. And once you've done then, you can add also the multi-type, so multi-point, multi-polygon, multi-line string. So there is the main kind of a spatial data set inside PostGIS. So this one is a multi-polygon. So what does it mean? It means that each geometry could be obviously a polygon. So you can have something like that. And in the same geometry, you have the right also to have any other kind of other polygons with them. And on each of them, you have the right also to put holes in your polygon. Once we've done that, we can check that the information. So here we want to grab the extent of the extent we just load the PostGIS vector dataset, and next we want to load raster data. So to be able to load a raster dataset, we wanna need to launch a query to grab them. There is a web services online, WMS. And here there is a query to grab the information and to retrieve data as an image from this server. But the point is that this server use another kind of projection. So here it's expressed like that. And this projection here is not expressed in the same SRID we just used, but in another. And this another is 4326. So we have to perform a transformation between the two kind of reference system to be able to grab information from the web service as an imagery and be sure that the data we want to grab are somehow related with our prior data set. So what we do, we create here an envelope. So an envelope is a simple polygon expressed only with 4 coordinates. So the 4 coordinates are the 2 corners. So you express your envelope with only two points. So here there is the first coordinate points, and here the other coordinate points. And only with 2 points you are able to express a polygon envelope. And you associate with this polygon the original coordinate system you want. And then you transform your envelope to another coordinate system. So here the transform function is related to that kind of operation. And we grab the whole extent of the new polygon we create, and we just then have to print it. And we print it with the right comma we want. So with this new extent, we are able to create our query to grab an imagery from these distant web services. Just before to go further, there is one site who's well known to deal with spatial references, and his name is Spatial References. So if we look, for instance, with a PSG, okay, we want to find information related to this projection system. And if we look to the other, okay, and this one is a worldwide one. So there is two kind of spatial references. One with really local and would deal with geometry put on a flat plane. And the other, the worldwide one, provide geometry were put on a globe. So here we are dealing with degree, and on the other one we are dealing with meters. And it's something really important to keep in mind. When here we are in a local projection, we are dealing in meters, and when we are switching here to a worldwide one, we are dealing here with degree. So there is nothing really related between the two, and if we if we don't use the right one, obviously the result will be something really unwanted. Okay, so the other point related to this query is related to WMS format. So WMS services. So it's a well-known services standard related to the way to deal between a client and a server to grab some imagery information from a server. So the request is related to here a getMap function, and we want to have to provide some parameters in to make it work. For instance, here we are looking for one layer, and the layer is called Sentinel-2 Cloudless. So Sentinel-2 is a constellation of satellites. And they orbit and they took imagery from quite the whole world, and they renew the whole imagery once a week. This web service provide direct access to this imagery. They provide it freely, so they didn't renew on each week, but time to time. Here they perform cloud post-operation to suppress the clouds who appear on the initial imagery acquisition. So the point here is to addition a different kind of pixel information was been took from different satellites at different time to remove all the cloud they can have to be dealt with. Here we found back the bounding box we want to focus on. So here, this bounding box is directly related to the coordinate we just compute. Here you got the pixel height and weight size of the image you want to grab, and here's the spatial reference you want to define, and there is not really a lot of choice with this release server. Once you've done that, we grab an imagery, and if we just look at it, so we just get a satellite imagery without any clouds on the sub-area we just ask. As I just said before, this imagery is provided with coordinate in degree, and we want to flat it back in order to be more convenient to be used with the other kind of spatial information we already load inside PostGIS. So how we do that? There is some different kind of function provided with GDAL, and GDAL is this library. I said before that GDAL is mandatory to use raster operation in PostGIS, and it also provides some tools. And you could use them from the command line. So there is one which is called GDAL Translate, able to perform some kind of transformation operation between one input raster and so provide the output. And here what we want to do is at the same time to took here one subset from our in fact, no. In fact, what we grab is only it's only an imagery. So we want to say as an output that the imagery is well referenced with this Rayleigh coordinate and is defined with this Rayleigh projection system. And in the second time, with GDAL warp, we want to change the coordinate, reproject them, and here we define the output spatial operation. So on the first step, we say through GeoDataScience Translate that the raster is well referenced with this Rayleigh coordinate on this Rayleigh projection system, and on the second time here we reproject. And why are we we need to do that is because the kind of imagery we grab is here a JPEG, and on this imagery, the references system is not provided. So as is not provided, we need to add it, and so we do. At the end, here we grab a subpart of the information, and if we look with GLinfo, with able to provide us some information about the raster, and what we can say is that the size here is the same we put in the output, and the projection is the right one. And here the pixel size information is about 10 meters. So that means that 1 pixel on the imagery means about 10 meters on the ground. And here we want to import the raster information inside PostGIS, and quite the same way that we use before SHP to PGSQL. There is another kind of command called here raster to PGSQL, able to deal with raster import information. Here we found back the same kind of option related to the projection system. Here again, some kind of option related to index, but there is a few more information really dedicated to raster handling. This one is the same than the previous -d, and it's related to copy. So with this option here, we want to perform a copy rather than insert, so it will speed up the import process. Here, the tiling auto, it's a quite important notion to, yeah, so there is a place here. What is about raster? Raster is about storing and manipulating grid data inside PostgIS. What is a raster? At the very beginning, you can imagine it as a grid. So there is pixel on this axis and pixel on this axis, and here you will find a value. But there is value in several, if you want, in several bands. So it's not only 2D, you can add quite as many bands as you want, and quite common information could be in one band. If you play with imagery, it will be quite common with 3 bands like RGB, but in fact you can put a lot of more bands if your dataset need it. So it's quite common with scientific data to play with something like 10, 20 bands because you need different information with really the same grade, and here you want to find your information in one band, but one another in another, and so on. For instance, if we want to represent the amount of precipitation on a territory, it could be represented as a grid, and the resolution I said just before that, for example, 1 pixel could be mapped to 10 meters on the ground, but you can choose the resolution you want, or you can. If we took one band, it could be one band for instance, the previous year, but one another band for the year before, and so on. So you can imagine to have somehow a time series with different kind of band, and then it will be quite easy to perform some matrix operation on them, and for example to subtract or to compare and so on. So you could use this raster operation obviously for imagery, but you could use this raster operation as a matrix storage operation with quite convenient way to perform matrix operation on them. The point is that obviously as you got at least a two-dimensional dimension for your data, and when you add more dimension, it could become high-dimensional information. You have to split it, because when you have to store it inside one single table inside Postgre, you can put it on a single column. Even if it fits, the performance will be horrible. So the point is to split all this data into some kind of patches. So for instance, we say that we want to take raster as, for instance, patch of 3 by 3. And obviously, if we extend a bit our schema, so here there is another patch, and so on. So it will be a way here on a single table to say, okay, here I have a 3 by 3 sub area of data here. It will be one rest line in my table, and so on, and so on, and so on. So the T here, the T option is related to the size of your tile. You can play with specific tile size, or you can let the loader choose the right size for you. And if you put tile option to auto at the really beginning, here you do, you want to compute the right tile size, you hope, you guess, for your data set. But if you want, you can here switch to another kind of so I was there. So you can choose another size, and here we choose another tile size, a bigger one. So if you look here, there is less row in the table. But if here we decrease by a large value, so we took only 20 by 20 instead of 200 by 200. Here there will be a lot more here of row inserted. So it's a way to say, okay, we perfectly know that in the later operation we want to deal with a larger amount of data, or instead we perfectly know we are dealing with really small patches. So it could be a way to optimize your storage or optimize your computation performances later. The C option is related to constraint. The both. The C option and the A option are related to constraint. So you can add some metadata in PostGIS raster metadata table. And once they've been put in place, it will prevent to store any other kind of data who are not really the same. So for instance, here we are aware that the pixel size is about 10 meters. If we add here this constraint, this information will be put in PostGIS metadata information and will prevent later that any other kind of information could be inserted with a different resolution size. Then we grab OpenStreetMap information. So we grab it from GeoFabric. We provide some quite easy already extraction convenient way to manipulate subpart of the whole OpenStreetMap dataset, and we use a tool. So OSM to PGSQL, this tool is not provided directly by PostGIS. It's an external tool able to deal with a PBF OpenStreetMap data and to directly load inside Postgre. So here again, we want to find some information about the spatial references. This one is related to the amount of memory you are able to dedicate to the loader. And it's quite you will need quite a lot of time to perform some transformation while he load the dataset inside Postgre. So if you have a lot of memory to dedicate to him, it will be quite something. It will be something really helpful to decrease the amount of time needed to perform the whole load operation. So at the end, there is three different kind of new table created inside our database. The first one is called OSM point. The other is called OSM line, and the third one is called OSM polygon. And inside these three tables, we want to find back all information related to OpenStreetMap, and they are not different. They are not distinct. So, for instance, in line, we want to find roads, we want to find a river, we want to find tracks, and so on. So it will be put in the really same table, and the only way to switch from one different data type to another is to look on the attribute fields. So this is really related to the way OpenStreetMap deal with this data, and so it makes this three table at the end quite big. And so if we look to what kind of attributes we can find inside an OSM table, there is obviously an ID, but there is the different kind of geometry, different kind of feature it's related. And for instance, there is attribute to say if it's a bridge, a boundary, an highway, and so on. Something quite important to check is to be sure that our data are valid once we perform the import. Because if they are not valid, here the GEOS or the SSE goal external library will not be able to perform any kind of spatial operation, and so could stop on error. So we want to be sure that all our data set is really valid. So here we check it by the use of isValid function. And if we want to be sure, we want to have to launch this kind of query on every kind of table storing Polygon type. Because Polygon type as a type of geometry who can be invalid. So, for instance, here, if you remind, there is a different kind of polygon we can find in a single multi-geometry, but there is some kind of geometry we are not allowed, so declared as invalid. And for instance, if you got a geometry here, we want to touch with one point, for instance, one another geometry like that. This is not allowed because on a topology point of view, we can't know if we are inside or inside. So this kind of geometry are not allowed, and in the same way, if you got one hole here, you can't have a hole who is not directly inside your geometry, or a hole who touch the geometry with that. So there is three different kind of invalid geometry, and there is a last one is related to geometry we are self-intersected. So, for example, this one is not something valid, but if you want to express it in a valid way, you can do that. So with that, there is two shells, but like that, like I did before, here you see there is only one shell. There is only one shell, and so one self-intersection, so it doesn't, it's not valid. But if you want to deal with, you do with two different triangles connected together. So on the same way there is an isValid function, there is also in PostGIS a function called stMakeValid, and if your geometry is not valid, there is a way to express it with the really same, or at least really quite the same geometry coordinates, but described in a valid way. And this geometry, as it's valid, could be then be used safely with GEOS. So it's quite interesting once we just import our data to check it, and if it's not valid, to fix it with ST make valid. As I just said before, the OpenStreetMap table put somehow everything in the same table. So for a single sub-area, there is quite a big amount of data. Obviously, if you want to load the whole data set, you bet that you want to have to split it, for example, with A-rated tables and so on. So at this point, we load our data set. It's a part with not so fun, but we have to deal with. So once the data are really put inside the database, and in a quite good way, then we can do a lot in spatial analysis. But since we are not able to load the right data set, it's not possible. To play with PostGIS and Python Jupyter environment, I use SQL Alchemy and GeoPandas on this example. So SQL Alchemy, when I create a connection, a persistent connection on Postgre, and we just have to provide a PG connection. And it's quite obvious, user, password, host, and here it's the name of the database. And GeoPandas is a way to be able to launch here a PostGIS query and to grab Pandas DataFrame information, and this Pandas DataFrame could be displayed directly as a tabular way. So if we grab all the information from our administrative data from Open Government data set, we grab the different kind of columns, and here the one related to the geometry. So here the geometry is expressed as text by GeoPanda, but it could also directly plot it to represent it as a map. So what do we need to do that? So a working connection, the query to grab all the information back from PostGIS. Here's the connector to retrieve the GeoPanda data frame. If we want to display here the attribute, and here if we want to plot it, we need ons to retrieve matplotlib to plot it on Jupyter. I don't know who is already familiar with Jupyter and IPython environment. Could you raise the hand? No one? Okay, so it's a quite convenient way to play with Python. So and yes, I need to launch this from Mac. And it's quite interesting because you are able then to play again on each part again and again. So when you are iterating to create a query, it's quite a convenient way to be sure that you are doing well. Obviously, this kind of representation could be improved. One way to improve it is obviously to see it bigger. So we change here the size of the display. By default, it could be something like 5 by 5, so we increase it. We remove here the axis value. So here the axis is related to the value about the coordinates. And I said before that the coordinates are expressed in meters in a flat representation. So here are the axis related to the Israeli coordinates. By this option, we just remove the coordinates axis, so it will be nicer. And also here we add another some additional information related to the style. So we can choose to pick up a color, and here to put some transparencies. So at the end, we have something bigger without any additional information about the axis, and with transparency, it's already something a bit nicer to see. Once we've done that, the point with PostGIS is obviously that we are able to deal with subtract information and quite advanced spatial analysis. So, for instance, here I want to grab only the kind of road where really the main road, so motorway, and we grab from OSM line at first only the road and then only the motorway. And if we look to what we got, we selected the name of this really highway and the geometry. So name and geometry. If we plot it, we've got some result, but we can just took back the tree lines that we used to plot the whole map, and add a new one dedicated to the motorway, and so we put the motorway from our sub area. In fact, when we import OpenStreetMap, we didn't import for the whole France because it's a really big data set. So for only tutorial, we focused on the sub-region. And at this point, what we want to do is somehow to zoom in, to focus only on the support where we want to have both our OpenGov information on the district area and on OpenStreetMap sub-region. So what is this area about? There is several sub-district, and so if we took every kind of feature from any of these ones, we wanna got the right district area related to these regions. So here we update district with only the part of the sub-region we want to focus. If we plot it, we zoomed here on this region, and we can see that the highway are quite fit on the map, but here you can see that there is some highway here will not not perfectly intersect with the administrative boundary. So what we want to have to do to have something a bit nicer is to perform an intersection. So it's quite it's quite one of the most common spatial query with PostGIS is to perform a test to see if two geometry intersect, yes or no. So if these two geometry here from OpenStreetMap and from the administrative boundary intersect, so if we do that, so here we perform the geometry intersection itself. So here it's a way to perform a spatial joint only on kind of geometry we are connected together, and so if they are connected together, we compute here only the geometry intersection itself. If I omit that, it will do really the same, but it will take a lot of time to do so. It will be really something we took a lot of time to end, because if I omit this one, there is no filtering on the two. On the table, we just on these two tables. So here, if I just let it like that, it will multiply all the lines result from this relay table by the other one, and it will take a lot of time. And it's only because here there is this ST-intersect that it will only deal with the really kind of geometry spatially related together. And this intersection is performed in a decent way because there is a spatial indexes. So if it's because there is spatial indexes that ST-intersect operation could be fast. If you omit one index on either this table or this other table, if there is no spatial indexes on one or the other, obviously at the end the performances will be really poor because you have to compute on each geometry if they could be related, yes or no. On the other side, if there is spatial indexes on both tables, is able to know really easily and really fast if the two geometry could be related. And it's only if they could be related that it will compute a bit more to be sure that they are related, yes or no. But the spatial indexes could help to pre-filtering all the data we are sure they are not related together. And here, the intersection function will perform really the intersection between the two geometry. And so at the end, we grab the motorway without any part of them, and you remind, before we've got some kind of highway who could be outside of our administrative boundary, and then we have something a bit nicer. Okay, once we are there, we can play with population. So here, a special request to grab information to display the main city on the map. So we grab a city as soon as they are bigger than some amount of population. So this put on towns, and we add a new layer in our map representation with towns. So at this point it's quite easy. And if we look a bit more carefully to this one, there is one first thing to see is that obviously there is a lot of cities who are close to the highway. But the next question is which city are the more farther than to the highway? If we look, for instance, to this one, at first sight, we can say, okay, this one is quite far away from a motorway. But if we want to compute it, how can we do to grab all the cities who are quite far away from a motorway? Because they are quite big enough compared to the other, but they are for some of them quite far or quite close to a motorway. So how could we do that? We want to keep the way to compute the administrative boundary restrict to the subpart of our region. And then we want to also keep the way to compute the main city on our subregion. And then here we want to also keep the way to compute the intersection between our highway and this administrative boundary. The only thing we add there is a union. So we add union function because just by using union, we want to use some kind of aggregate function. And so all the line on the geometry provided by ST intersection will be aggregate in a single geometry. And then we could use quite easily an ST distance function to order all the town from the one who are big enough, and we want to order this town related to the motorway, and we order them in by taking the more bigger distance at the top of the order, and to keep the the 5 first. So we keep the top 5 of the city who are far from a motorway. And if we look, we called these dataset outliers. And if we look at it and plot it in red color surrounded by a black border, it will be this ones. So it's a way to perform a spatial operation and to grab information. It's interesting by the way we create by iteration this kind of spatial query. By first we create a sub-data set, and at the really end we perform the right operation we need. So we can by CTE deal with several iteration in our request. First, we compute only the subpart of the dataset we need, and at the end, we compute the really kind of spatial data analysis we want. Another example here is related. If you look on this, there is here a lot of dots who are really close together because of administrative arbitrary district. But somehow all these dots are related to a single big city. And what we want is to aggregate them, this one, to not have to deal with a lot of little dots put aside. So there is a function in PostGIS called stClusterWithin. We precisely do that. If we look on the documentation to stClusterWithin, so what this function is supposed to do is to aggregate and return an array of geometry collection. And the aggregate is related to a distance. So every geometry closer than this distance will be aggregate. So what we do there is to aggregate this function, and with a minimum bounding circle to create a circle able to represent the different plot we just grab. So as a result, if we put them here, we've got this plot with a new aggregation. And here, once we are able to grab these new circles, the point will be to retrieve here the centroid of every city, to remove the city where already intersect the urban area we just computed before, and then to add to them the centroid of the urban area we just compute. So in fact, we took all these dots, we remove every single of these ones, and we add the centroid, the center of the new geometry we just compute. So if we plot this new center, we call them centroid. If we plot them in green, we've got several points with this green computation. So what's the point there? The point is to see the ability with spatial query to really deal with quite iterative computation to switch from one dataset representation to another. Because you always have to change it to be able to use the right function you need, to express the right display you want to, and so on. So it's interesting to see that we always perform by iteration, and there is a lot of function in PostGIS and way to express it in pure Postgre to deal with our dataset. One another function is called Voronoi, is related to the ability from a dataset point to create some cell on the map. If we look on the result, from each dot, you will try to go as much as you can on this direction, and from this one another, you want to try to do as far as you can, and at a moment, the two limits will touch together, and it can go further here because it does the same on this way. So it's a way to split the whole territory by using as an input the whole dataset point we just computed before. So what does it look like here? We keep all the information we just compute before, but here we want to add this part related to Voronoi Polygon. We'll do it. So I launch the computation again. Okay. So just launch it again from the beginning to be sure that every kind of data are well assigned. So it will take a few few seconds. And so once we play with only the subset, it will be quite fast. Okay, we are there. Okay. Okay. So here, if I comment this part to keep only c'est ça que je vais garder. I didn't keep the right part, sorry. Okay, so if I comment the intersection function, if I just launch it on the pure Voronoi polygon, it will do on the whole data set. But here you can see that, in fact, it's not really what we want, because here the cells are somehow go to very large B-box setting. So we really need to restrict it only to the sub area we are interested in. And this sub area is called here, it came here from the array table, this one. So here, it's why there is this intersection to restrict it. One another kind of thing you can do with PostGIS, or at least you won't have to do, is to be sure that your data are well integrated. So if we keep on our data set with Open Government data set and OpenStreetMap data set, there is two different ways to express the boundary limits area. And if we just count the two data sets, there is a difference between the two. So we already know that in the two data sets, the data are not equals between the two. We can quite obviously use the attribute part to know which data from OpenStreetMap are not in the Open Government dataset because it's a smaller part. And we do that with an outer join. But the interesting part is here to look to a way to perform it with spatial, in a spatial way, to be sure that even if two cities have got the same name, and we perform the join on the name, even if both have the same name on the two datasets, are they really the same on a geometry point of view? So there is a function called Hausdorff distance, and Hausdorff distance here is dedicated to compute the way how two different geometries are really the same or not. And they compute it by producing as an output a distance. And if the two geometries are really different, the distance will increase. And so here, what we do is to compute this Hausdorff distance on the two kind of data set. And as a result, we've got, for a lot of data, here, a value with really somehow a smaller value. But at a point, the data really increase in value because here, in fact, there is some name who are used several times in the same data set. So in fact, there is two cities who are called the same. So if we do the join only on the attribute, in fact, it doesn't work because there is two cities who have the same name. And this Hausdorff distance is a way to be sure that the way we perform the join is the right one, because even on the spatial port, they are or not the same. So here we know, because the value is really really high, that these two features are not at all the same geometry. And the last example from this analysis is related to raster. So here we import a raster from related to light pollution. So it's aerial point of view, took at night from a satellite. If we look on the information on it, so it's a worldwide imagery information expressed here in degree. And with only one band of information. If we look to switch if we switch from the whole open government dataset to grab the extent of the geometry and transform them to degree representation, here we've got the coordinate expressed in degree from the whole France open government dataset. If we translate it to switch from here we took only a subpart of our imagery because it was a worldwide one, so we took only the part related to the France. And here we change by reprojecting it to a French local representation system. And here we check that everything is smooth. So we can see that we change the local representation. Here the pixel size is about is a bit less than 1 kilometer per pixel, and we still keep one band as an output. We just import it, and we are able to look at it by using binary and ST-union on all the data we are stored in a raster. So this tutorial was dedicated to give you first introduction to PostGIS and what you can do with spatial analysis. Do you have any kind of questions, or what do you expect with the use of this kind of library? Do you have any question, in fact? Yes.
Unfortunately, the speaker is off the mic.
Sorry, could you just repeat the question? Yep. Mm-hmm. There is a lot of different fields who are interested in this kind of spatial analysis. There is people who work in the Earth observation field, and their point will be to grab scientific Earth observation and to use this kind of information inside model. To try to represent the way different kind of sensor grab Earth observation dataset. So, for example, if you're interested in water management, you are interested in the way the river behave. You are interested in how the river are connected together. And for example, if there is a lot of precipitation, it could lead to flood. And so, if we are able to deal at once in the same database system with precipitation, with the elevation of the mountain, with the river connected together, you could compute a model who can deal with how the precipitation are gathered on the same place, how they are able to go down the mountains, and so at the end you got information on which kind of in which cities are concerned, and which people do you have to warn to say them, okay, you have to move. So one kind of example. One other kind of example, it will be related to people who want to build something. For example, if you want to build a new highway on this kind of topic, you have to be sure that there is nothing on the way when be an issue for your project. And so these kind of tools are able to deal with the representation of several different kinds of data set to be sure that there is nothing somehow connected by attribute or by spatial relation who could be an issue for your whole project. On some other kind of project, it will be related to the way you manage your city. And so on this, if you are able to represent the networks on your city, for instance, your transportation network, it could lead to a better way to provide services related to transportation. For instance, if you have a nice road transportation network put on your spatial database, and you've got also, for instance, the bike, the subway, and so on, at a point you are able to create a computation on the smallest and quicker way to go from one point to another. It's one another example. And there is, in fact, a lot of examples because somehow there is a lot of different fields in industry who are concerned by spatial. In fact, if you look to your own data set, there is a lot of spatial things in it, and the spatial could be expressed by coordinates, but it could be also expressed by an address. And so a way to perform the transformation between an address and the coordinates and the reverse operation is also a way to begin to play with this kind of system. Another questions? In English or?
Where can I take the materials that you are using now?
The question was, where did I took the material? Where it was you on the tutorials, all the materials was took from open dataset. It was designed to be opened. It was answer your question. Yeah, the code was wrote for the tutorial. So this code is available on GitHub, and you can use it. It's already online, in fact. Yeah, I will switch it because this one is on my local app. This one is a public one. Other question or reaction?
I'm going to speak in Russian. I used quite often spatial issues, and I face such a problem that geometry doesn't accept corrections through make valid functions. It's not always correct, because when we divide it into valid polygons, one polygon space was much bigger.
I will repeat to be sure that I already understood your question. That I understood is when you already use the spatial function, at some point it could lead to invalid polygon, and that could lead to an issue because you are unable to do something meaningful with invalid polygon.
Yes, but the problem is that when correcting the invalid object, make valid function did not work 100% correctly. It changed the space.
Okay. So I repeat again. You precise that even if you use st make valid function, it's not 100 function. It's not 100 for sure. And sometimes there are some slightly differences in the way you express your geometry representation. That's it for your questions? Okay. Related to st make valid functions, so one thing to know, when I present the case of invalidity, I said that one case of there is several cases of invalidity. Invalidity are quite always related to polygon. A point is always valid. A line, the only case where a line can be valid if the whole data set of a line is no more than a point. So for example, if you've got the starting point of your line, but you don't have another point, or if all the other points from your line are somehow on the really same point, you've got an invalid line. So it's the only case where your line will be invalid. And all the the polygon invalidity somehow are related to the case when there is a topology inconsistency, or if there is a doubt on your topology. For instance, if you've got here the external ring from your polygon, and here you've got the internal ring, and this one is put aside, there will be an invalidity. And I come to the way STMakeValid makes the transformation. I said here that if you want to express that, you have to express it with two triangles. So on this really kind of transformation, STMakeValid will transform your first representation with invalid into a valid one, but it will switch the type. So the first thing to have in mind is that if you use STMakeValid, for instance, with a multi-polygon in input, as a result, here, don't wait for multiple polygon. Here, it will be something more abstract. It will be something like geometry collection, with the more abstract way to express a geometry. So if you wait because you give him a multiple eigen to have here directly valid multiple eigen, it's not the way it could behave, because he have to somehow increase the abstract level to be able to find on his feedback to have something valid. So the trick here is to extract the part of information meaningful for you on this one. And in some use case, it will be quite easy because you only have to use geometry collection geometry collection extract. I'm not that sure if the extract is before or after. Check it. Collection extract. So ST collection extract, and you can, with collection extract, grab only, for instance, the area part, the surface part of your geometry collection. So ST collection extract on this one, and the parameter for the surface is 3, and you want to retrieve all the surface. In most cases, it will be good to perform the validity transformation, but in some use case, it's not enough. For instance, if you've got a polygon like that, here, this part is really on the same dataset points. If you perform a make valid transformation, all this part of the coordinates will be transformed in a surface, but this part here will be transformed as a line string. So here, in the geometry collection dataset result, you have something somehow mixed between your surface part and here with a line string. And so if you perform a collection extract, if you want to grab the surface part, it will be with 3. But if you want to grab only the line string part, it will be 2. So in a lot of use cases, it will be quite easy to retrieve the valid data set, but it's not always possible. So there is indeed some use case, it will fail. Sorry?
Вы говорите, пожалуйста, мне, а то я вас не слышу. Да. Can I draw an example which my use case? Can I?
Self-intersection. But my result, object, result.
It just said on his use case, there is a lot of self-intersection. Yeah, you can do it. There is a place. Yeah.
Был объект очень большой,
There was a large object with a large number of dots, but there was a self-intersection at this point. After we applied this here, the result was and the area S1, so they were different. Even that area became bigger than the initial object.
If you found that, it's a bug.
Okay, but I was using the version PostGIS 2.2 if memory serves. I did not check 2.4, but I saw this was 2.2. And it was only 0.5% of all the cases I saw, so it's very rare.
So, the STMIC valid transformation indeed is done by geos. So somehow the point is not really your PostGIS version. The really point is your geos version. And here on this relay use case, when you want to do the make valid transformation, here you've got only one polygon, and as a result here, so as an input you've got a polygon here as an input, and as an output you want to retrieve a geometry collection with here at least one polygon, and here one another polygon. But if on this one the coordinates have changed, it's a bug. It's not supposed to be so.
Basically, make valid always the correct things. We were quite okay with that. But we deal with the registering properties, plots of lands, for the land cadastre. So, to calculate the price of a square meter of a property, you use the intersection of the land plots and the estimated value of this land. And there are cases where properties are at the intersection of a number of various districts. when we want to understand, let's say this one's bigger. This has the maximum area. So when we estimate, we need to take the price using the price of that particular area. But when we change it, when the area grows bigger, then this grows bigger. So in case of intersection, is when we intersect the line plot with the estimated price, we will take the wrong price threshold, and we'll get an incorrect price for the user. Maybe in this case we only have to do it manually, to check manually and to calculate manually, because I haven't seen any other opportunities so far.
I repeat it again, but if you find some use case where estimating valid result don't keep your coordinates, it's clearly a bug. So if you are able to create a report on PostGIS, it will be helpful. That's the first point. The other point is there is a quite well-known old trick, one was used before estimating value. Yeah, ST buffer with a zero value. And it was used when estimating valid wasn't available, and by using buffer with zero value, it could be something to correct some kind of invalidity, but not in self-intersection use case.
Then what can I use to be on the safe side? The make valid does it correctly, but I didn't know at what point in time I'm going to face this issue. When do I need to use this one? Should I better use this always, or should I try and identify things after we have done the major calculations?
In your really issue, the first thing to do is to check again with the latest GEOS version available. So first one is to use with the latest GEOS. If you still have this issue, is to create a report, because it is clearly not something as a feature. And the third one, if the report, the bug report took time, you could try with ST buffer what kind of result do you get with ST buffer on it. But the first one is to try with the later GEOS.
Хорошо, спасибо.
Okay, thank you. Будьте добры, повторите вопрос для всего зала на русском.
Могли бы вы посоветовать какие-то библиотеки для визуализации данных
Could you please recommend libraries for visualization, like Google Maps or similar libraries?
There is something I didn't. So the question was, could you recommend some library for display? On this tutorial, I focus only on IPython, Jupyter display, but clearly it's not that common in JS field. And for display. If you want to have something quite similar with Google Map in the open source, there is open layers, and it's clearly a well-known library dedicated to web representation. So how could we use open layers tied with PostGIS? There is in PostGIS some export function. So say as GeoJSON. And for instance, there is a st as a GeoJSON export function. If you use this one, does it still work or not? No, it's still old. You can directly grab some geometry from PostGIS with this function, translate them in GeoJSON, and GeoJSON could be displayed, for instance, with OpenLayer. So it will work if you have a quite small amount of geometry to display. If you want to display far more geometry, but not through a browser, so not on the internet, but on your desktop, one well-known tool to do that is QGIS. So QGIS. So that's a well-known tool to display your information on your desktop. Well, I can show you something. I just need to connect. Okay, does it work? Yes. Okay. So it's quite slow because the data set is on an external server. So it's why it's slow, because they had to grab all the information through over the internet. But here, with QGIS, you can display all the information that you already stored on PostGIS. And something interesting is that you can also directly perform query. So here I'm on QGIS, and I can perform any kind of spatial query and display it. So for instance, je suis pas sur la même base. Voilà. Je vais faire ça. Okay, so I grab from OSM the highway. Well, so I can display them. Okay, so I do it again. It's supposed to work. So. I wasn't connected, sorry. Okay, I wasn't connected to the database. Okay. Okay, connection is the right one. Okay, so I will not finish this one, but yeah, the point is QGIS is the right tool to play with all the kind of information provided in PostGIS. So you can play both with vector and raster, and you can also directly create your function, your spatial analysis, and display it directly in QGIS. So it's a common way on a desktop area to look to what you've got in your data set, and also to zoom in, to zoom out, to query by click, and so on. So as long as your data set is big, it's a really common way to deal with. Yeah. And open layers came only when it's on the internet. Other kind of question, reaction? Thanks a lot.